So this is a bonus example. It's another example of graphing a piecewise function. So I encourage you to, stop the video and try it on your own first and see, if you're able to do it, and then watch the video to see if you did it correctly. Or if you get stuck, then watch the video and then you can see maybe what the sticking point was. Okay, so here's our piecewise function. It's coming in 3 pieces again. They don't always. Sometimes they just come in 2 pieces, but this one's coming in 3 pieces. So the first part is going to be if x is less than -1, and then for the table of values, I'm going to have x, and then it's going to be x cubed, right? Now you could write f of x equals x cubed. That's what I did on the last example. Okay, so I need numbers that are less than -1. So maybe -2, -1. Yeah, okay, I don't want a lot of numbers because if I put in -3, that's already going to be huge, right? Okay, now at -1 though, is that going to be an open or a closed dot? That's going to be open. I always like to write it on my graph so I don't forget, or in my table of values so I don't forget. Okay, now plug those in. Cube -2, you get -8. Cube -1, you get -1. Okay, we can graph these pieces then. This might be a little problem. My graph's a little big. Okay, so here's -1, -1. That's going to be an open dot, we said. And then the other one is down here at -2, 8, right there. And so I have this piece coming up here. Whoops, I'm off one. Let me erase that. -2, -8, so it's over here. And so it's coming up and it's starting to curve a little bit. It's going off toward -infinity in that direction, and that's just that piece. Okay. So now let's see if we can go to the next piece. Let's see, this is going to be if x is between -1 and 4. So I'm going to have to make sure on my table of values that I include both -1 and 4. And then maybe I want to include some other points as well. And these are just points I pick. I could pick 1 and 2, or 0 and 3. I like to pick integers. But I need to note that at -1 it's going to be open, and at 4 it's also going to be open, okay? Because we don't have the equal to parts on the -1 or the 4. This is x between -1 and 4, not including -1 and 4. Now, the function is constant. So here's my x. My output's going to be -2, no matter what. I didn't really need to pick 4 points, but I did. Okay, so -1, -2. That's going to be an open dot right there. And then it's going to be 1, -2, and 2, 1, -2, 2, -2, and then 4, -2. So I have this long constant part right there. That's the constant function at -2. Now, I noticed that this function's not defined at -1. That's okay. It just means -1's not part of our domain. I could have typed it wrong. I mean, that's certainly possible, but I'll just go with what I have typed. Okay. Now we get to do the third part. So our third part is going to be if x is greater than 4. Again, we'll have to use 4 so that we can see what's happening there, but that will be an open dot. And then I want numbers bigger than 4. So I'm going to be doing the square root. So I like to pick nice numbers like 9 because I can take the square root of 9. Okay, so the square root of 4 is 2. Square root of 9 is 3. And then I'm kind of off the chart, so I'll just stick with those two. And so it's an open dot at 4, 2. So 4, 2, open dot. So apparently 2 is not part of the domain either. They didn't ask us what the domain was, but so that we know. And then 9, 3, that's a point on the graph. And so it's a square root function, so it's going off like this. There's a little bit of a curve there. Hopefully you can see it, even though it's in green. So if you were thinking to graph something like that, you would be right. Okay, so good luck with these. They take a little bit of practice. They're a little tricky, but I think they're kind of fun because they're just so different. Okay.